Hello everyone. Welcome to the June 25 weather briefing. My name is Liliane Hofer and I'm working at Geosphere Austria, not at the headquarters in Vienna, but at the regional office in Salzburg, let's say quite in the middle of Austria. I am a part-time forecaster, and when I'm on shift, I always like to start with the Airmass RGB for gaining a total overview, and that's what I will do today. So here you can see the Airmass RGB. On the right side, you have the recipes. So we have the two water vapor channels, two infrared channels, one of them the ozone channel. And then you get this image where you can see the most prominent cloud features and also which dynamic processes are going on. So you have over the Atlantic the frontal system, so the cold front over the Atlantic, and then the warm front region over the northern parts of Europe. We have this images taken from, or the satellite images from 6 UTC. We have already some early morning thunderstorm activity going on over the southern parts of Italy. What more do we see? We see there's a widespread area with little or nearly no clouds from the Iberian Peninsula over France, Central Europe to the Black Sea. So there seems to be widespread high pressure region. You might know the Airmass RGB, then you know that in the reddish colors we can see the PV anomalies, and this here over the Atlantic it looks like a trough. Then we have in front of the warm front also PV anomaly. Also in the area of the thunderstorms over Italy, we detect some reddish colors, and here this seems like a really large, widespread red area. We will take a closer look at that later, but first, the overall weather pattern here in the form of the geopotential height at 500 hectopascal. So we have this, it's not the perfect omega shape, but it's like, an ongoing omega shape. So we have this ridge over the western parts of Europe here, this upper level low, which triggered these thunderstorms over southern Italy. We have here this trough we already mentioned before because of the PV anomaly. And yes, that's what it looks like. And this ridge over Western Europe brings a widespread, stable weather situation. Let's take a look at the height of the 1.5 isentrope. And you can see that for most parts, this coincides really nicely with the red color, with the PV anomaly, as we would expect it to do. For example, over the trough over the Atlantic Ocean or the upper level low. I've mentioned this large red area over here in the right corner, and you can see this red area does not coincide with a PV anomaly. So, and this is due to the fact that this shows an area of really hot and dry air masses, and that's at 6 UTC. And I bet if you take a look at this area now, the red might be even brighter and more widespread because it's not due to some dynamic going on in the upper levels of the troposphere, but due to the really hot and dry air masses in this region. So now let's get a more detailed look into the weather situation, and I would like to do that with the True Color RGB from the MTG. As you might probably know, this RGB has a night mode and a day mode. So you can see the night mode still on the left side of the image in these bluish colors. That's what it looks like during the night. But thanks to the high solar angle already at 6 UTC, most parts of Europe are in the day mode. And so we see here some nice features. We see all the clouds, also the low clouds, which we cannot see very clear in the Airmass RGB. If we zoom a little bit into the thunderstorms, you see this nice shadow on the southwestern part of it. So this is giving the whole thing like a 3D component. So I really like this RGB very much. If you compare the thunderstorm cells to the lower clouds over Croatia and Bosnia, you can see there is no shadow on the southern corner because these clouds are too low, but this thunderstorm clouds are really high reaching and therefore they create this shadow. And I think the shadow on the right cell is even more pronounced than on the left cell, which might be a sign that this is even higher reaching. So it's very good visible and it looks really impressive. What more do we see? So we also see this kind of hazy features over the Mediterranean Sea. And at first you will think, okay, this might be dust, but you probably all know from the last days or weeks, this is no dust, as you can see clearly over here. And I don't want to say no more because my colleague Andreas is dealing with that phenomenon later on. How would the dust look like? If you don't know, it would be like pinkish features. Probably here we have some dust in the air, but it's not that pronounced. The dust RGB, it can be used, as the name implies, for the detection of dust, but also for the detection of thin cirrus. And we can see some thin cirrus in the southern parts of Spain or over the Alps, central Germany, Poland. These black colors indicate really thin cirrus clouds, which are, for example, not visible in the natural color RGB or things like that. So, but the dust RGB is, it's really good for that. And there's also this new RGB, the so-called Cloud Type RGB. You can see the recipe here on this side. As you see, it's using the infrared and visible channels. So this product is only available during daytime hours, in contrast to the dust RGB, which is available 24/7. But you can see here also very nicely the thin cirrus here in red colors. So especially the red beam has a large contribution when it comes to cirrus clouds or thin cirrus clouds, because higher reaching ice clouds look kind of yellow, but this bright red indicates thin cirrus clouds over land. Over sea, the red might not be that bright, as you can, for example, see over the Red Sea. So over sea surfaces, it's not that pronounced, that red. Yeah, what more can we see? We can see low clouds in these cyan or bluish colors. Thick clouds appear greenish. Yeah, I think it's also really nice to look at, I have to confess. But for thin cirrus, it's really good to use during daytime hours. If you compare it with another new RGB, with the cloud phase RGB, you can see that cloud phase RGB is definitely not for thin cirrus detection, because you can barely see it, especially these cirrus cloud bands over the Alps. You cannot really see them in the cloud phase RGB, but as the name implies, this RGB is for the distinction between water and ice phases, and for distinguishing the particle size on cloud tops. And yeah, the big difference why the cloud phase does not see thin cirrus too good is in the near infrared 1.38, which is really doing all the location of the thin cirrus clouds. So apart from that, not much is going on over Europe. Widespread high pressure weather, as I said in the beginning. So let's jump to the outlook. So how will the weather continue during the next days? So there's tomorrow, Thursday, we still have this pronounced ridge over Western Europe, and there will be no major changes until the weekend. So this is Saturday. Here's this trough might probably lead to some more thunderstorms in the afternoon over the Alps. Let's see what happens. And then if we jump to the beginning of next week, there might be some changes. The ridge is retreating more to the south, and in Central Europe, a westerly flow looks like to be dominating in the beginning of next week. But yeah, let's see what really happens. There's still some time until then. What does the ECMWF fields say for the weekly anomalies for the next week? So I have to say that the initial state of these model fields was yesterday. But it looks very pronounced that the next week will be too warm in wide parts of Europe, as you can see here on the left picture, and on the right picture you can see the weekly mean anomaly of the precipitation, and it will not only be too hot but also too dry, especially in Central Europe. There might be some, it might be a little bit too wet in parts of France, but in wide parts of Central Europe it will be too hot and too dry next week. So let's see what really happens. And yeah, with this image, which I found today of this nice Karman vortex streets, I would like to thank you for your attention, and yeah, hand the microphone, so to say, over to Andreas.
So welcome also from my side. My name is Andreas Wirth. I'm working in Vienna at the headquarters of Geosphere Austria, and more precisely in the remote sensing department. And for today, as a special topic, I have chosen the Canadian wildfires and their implications, or with other words, the smoke that came over Europe. So let's have a look at that phenomenon that happened, started two weeks ago and affected the whole last week, Central Europe. So these are two photos I got from a colleague from Croatian Met Service. And you see clearly the difference above the 10 June and below 11 June. So 24-hour difference, and from blue sky to a very milky sky. Maybe most of you could observe that last week over the place where you were, because it affected whole parts of Europe and also parts of the Mediterranean Sea. So there was a drastic change in the color of the sky. It's not dust, it's another kind of particles, and the color is more milky. For dust, it would be more this reddish, brownish color. So let's have a look at Canada, the origin of this smoke. And this here is an RGB they use there quite a lot, because it depicts on one side the fires. You can see these red dots here. And on the other side, which is also very important, the smoke that comes from these fires here over big parts of Canada. They call this RGB land, cloud, and fire RGB. And it's a little bit similar to our natural color RGB that we use with MSG. But instead of 1.6, they use 2.25 micrometer. But it looks very similar. So this RGB is suited to see smoke, okay, and fires, but there's another RGB, which is called the fire temperature RGB, which is more sensitive, much more sensitive to the fires, because it has other channels that are sensitive, like 1.6, 2.25, and the 3.8 micrometer channel. All of them are sensitive to fires, and you see here these hot spots where the fires are. Unfortunately, in this RGB, you cannot see the smoke. So you have to use a visible channel to see the smoke, which is not included here. So this is end of May, both images, and then a little bit later, 2nd June, we have to transport over the Atlantic towards Europe, and you see it here in this in this True Color image. Here, this brownish color at 12 UTC. And interestingly, if you look a little bit later, here see again the transport of dust, but the color changes. And I think this difference between brown and this more whitish color is the same constituent. It's the smoke or in the air in higher levels is mainly due on one side probably due to the solar angle. 18 UTC, the sun is more to the east, so we have a more direct sunshine on this smoke, while the previous image for 12 UTC, it's standing over Greenwich, and there's a very low incidence angle, which increases a little bit the scattering in this area. And you must also know that this image is Rayleigh corrected, so this also might play a role in the depiction of the color. Interestingly, there is another RGB, a new RGB that is available now with MTG. It's the Cloud Type RGB, and here you see the reddish color that comes from the 1.38 micrometer channel that indicates this high smoke clouds. So Lily has shown previously that this Cloud Type RGB is nice for depicting high cirrus clouds, but obviously it's also good for high smoke clouds. So here in this area, when it comes from Canada, it's quite high up in the atmosphere. I was talking to a colleague from the air quality department, and he sent me some other satellite measurements from Sentinel-5P. We have the aerosol index. That's again 6 days later. It's on 8th June. And you see the aerosol index with high values over Germany, and that came down to Austria, to Central Europe. And the same for the CO load. It's the total column here of the CO, and you have higher values over the Czech Republic and also over southern Germany, which will later on affect also Central Europe and Austria. So we have in the mountains an observatory that measures the air quality. And you see this graph here that measures the carbon monoxide and the sulfur dioxide in red and orange lines, respectively. And you see that the red line of the carbon monoxide has a sharp increase when this dust cloud arrives. This observatory is in 3,000 meters height. So we have a sharp increase here of the CO, but not of the SO2. And the reason is that this is the typical sign for wildfires from forests. If it would be smoke from volcanic ash, from volcanic mountains, volcanic eruptions, or from fossil fuel, then we would have an increase in SO2. But since this is biomass burning, there's no increase of SO2, only the CO is strongly increased. So they also, in this department, they also did calculation of the origin of the smoke plume, and this is the graphic they showed me. So you have here over Canada, Nova Scotia, an area with high probabilities where the smoke plume comes from. So the origin is here, this blue point, and there's a backward calculation of the trajectories, and then you come to the origin area somewhere here over Canada. So this is well proven by our models that the origin of the smoke is from Canada, but you could also see it in a satellite image. When the smoke arrived, here is 9 June already, last week. You see it clearly in the True Color image. You see it along the Alps, but you see it also inside the valleys of the Alps very clearly here over Switzerland, northern Italy, a little bit over Austria also, but very strong smoke clouds over the northern part of the Alps and the southern part also. Yeah. Interestingly, this here is a chart of the measurements of the particulate matter, PM10, and you see that all of that, it's the same day, but a few hours later in the night, all of them show good values. So it's green, light green, dark green. That indicates light contamination with particulate matter. The stations are near the ground, which is a sign that this smoke is in higher levels, so 2, 3, 4 kilometers, but not on the ground, not yet here. So it came down to the ground later on, but on 9th June, it was still, the stations did not show a strong contamination near the ground. Here again, it spread also over the Mediterranean Sea, and you can see it looks a little bit like the structures in the water vapor image, the structures of the dust in the true color image. But unfortunately, the true color image is not able to depict the height of the plume, of the smoke plume. So you can maybe imagine where it is. And there's a big help from the Cloud Type RGB. It either depicts the smoke plume here in red colors, you see from the near infrared 1.38 micrometers, or in green when it's only visible in the visible. And now I have a short question to you. Maybe you can mark it as a L or a H, where the dust is high, the smoke is high, or where it is low. And according to what you have heard previously, like the high Cirrus detection, you might be able to solve that. So mark an L for low smoke and H for an high level smoke. So remember that the Cirrus was detected in the 1.38. Any ideas? We have a first guess. Yes. This is the reddish part. Is it high or low according to your guess? What do you think? Don't be shy. Yes, that's true, but I refer to the smoke. So to this area here, the greenish and the reddish area. And Ivan, you're an expert, you know that? Yes, that's correct. Fine. Thank you very much. I'll proceed to the next slide. Here you have it, the high level smoke and the low level smoke. And I think this is a very good tool here, this Cloud Type RGB, for detecting the height of the cloud. We are happy that this event does not happen too often. The last one I remembered was in 2023 and affected the Mediterranean part, not Central Europe, but more the Iberian Peninsula. So it happens now and then, but luckily not too often. So, and the last slide I have for you is the LiDAR profile. There were lots of them sent by emails and in forum in the last week, and you can nicely see the cloud here. This is a time series from Monday to Tuesday noon, and you see the reflection in the LiDAR of the smoke coming down to lower levels. Yeah, can be nicely seen. So that's all I have collected about this phenomenon that happened over Europe